Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fikri bin Ansarudin from 4BMMD4824. Today I will present to you about Automotive Component Manufacturing Assignment 1. The automotive component chosen was the NK RPF1. NK is an official supplier for the McLaren Honda Formula 1 team. The RPF1 was developed using the same technology as the Formula 1 race wheel. NK's dual open stance spoke design is used on the McLaren Honda Formula 1 race wheel. The twin spokes achieve better stress dissipation on curves, hard braking, and extreme race driving. NK's pocket design around both circuits increases rigidity and keeps the wheel cooler during aggressive race driving. Shaping by the most advanced technology process reduces wheel weight by 10% to 50%. Next is the drawing for the wheels, and at the bottom of the slide you can see the size limiter, size width, inside board pattern and board diameter, which is provided by the NK catalog. Next is the manufacturing process involved, which is from the MAT to the heat treatment, machining, shot blast, and then finally finishing. For the most advanced technology, it is the manufacturing process combining spinning and forging. The aluminum alloy will be poured into the mold first, then the casting will be spun at super high speed and forged at the same time. Heat treatment is a process of heating the metal, holding it at that temperature, and then cooling it back. During the process, the metal part will undergo changes in its mechanical properties. This is because the high temperature alters the microstructure of the metal. Next, the machining is any of various process in which the part is trimmed into desired final shape and size by a controlled material removal process. Shot blasting is a technological process of removing various impurities from different surfaces by using abrasive. It is used for surface protection and also prior preparation of surfaces prior to further processing such as welding and painting. And the finishing is mainly paint. For the software to be used, the CATIA software was chosen. It provides both CAD computer aided design and CAM computer aided machining. It will be used as it was easy to use to design and do the machining simulation. The desired part will be designed first, followed by selection of machining tools and machining process before generating the ANSI code for the CNC machine. It also can do the part analysis. So first of all, we have to apply the material. For this case, we will apply the aluminum material. If you look at the part body, we have the aluminum applied. Next, we will apply surface slider and also clamp so that the part won't move and the degree of freedom will be restricted. And then we will apply the force, which is this time we will use surface force density, and we will set up the value. We will set force in x-axis as negative 2500 and y-axis to 1500, so that we get the angular force direction. And then we'll do the data computation. And then we'll get the result. To see it more clearly, you can click on the deformation icon and see the deformation done to the part. Then we can also check the von Mises stress and see the critical part, where the critical part in stress. the von Mises will show where the part will fracture and have maximum stress. Then click on the displacement icon to see the displacement done. And then this is the principal stress view. And lastly, the precision, where it shows the area which affected the most. So in this case, on the spoke, which will be deformed after affected by the force. I'm really sorry for the bad quality video. And then we can also animate this emotion. As you can see, the changes from the original to the deformed part. Then we can generate the report and select the folder we want to save. Then generate the report. Then open the report to see the full data result. This is the computed data from the user. This is the computed material characteristics, which I use the default characteristics from CATIA. Then we have the deformation image, von Mises stress image, and all the other image with translational displacement. This is the estimated fracture and deformed image. Next we will do temperature test to the part. Select the temperature icon and select on the part, and then set up the temperature, which is this time we set up as the 500 degrees Celsius. Then again compute the data to enter the data to the system. And then click on the deformation to see the changes. This happened like this because the part has been expanded larger than its original size, so it expand larger than its clamp itself, so the clamp is smaller than the deformed part. When we play the animation, we'll see how the deformation occur, how the expansion occur due to the high temperature. This is in von Mises stress view, and then next we'll go to the deformation view, which will, when we animate, it will be same. Then we will generate the report. As we can see, there's no image on the report, so the value computed need to be revised and computer can. So thank you. That's all from me.